All right, everybody, welcome back. This is the second part of the lecture on empirical research. So we covered case studies in the first part. We also gave a bit of an introduction. Now we continue with controlled experiments, and after that comes surveys. So what are controlled experiments exactly? And I lost my mouse pointer again. So they're defined as an investigation of a testable hypothesis where one or more independent variables are manipulated to measure their effect on one or more dependent variables. If you want me to put it very simply, this is a cause and effect study. So you're trying to find out if X is causing Y, while at the same time, of course, making sure that there's no other variable like Z that could have this effect on variable Y. So in principle, we are studying causality with controlled experiments. So main characteristics, as I mentioned, we study relation between variables, especially cause and effect relationships. These are studies that are done in vitro or else in the lab. And there, the whole point of doing the study is in the lab is that we try to eliminate confounding factors. This could be other variables that are causing the independent variable to be changed other than the dependent variable, of course. So we try to control everything to make sure that it's only the cause and effect that we can observe between the dependent and independent variable, and nothing else comes in between. In many of these studies in our field, in software architecture, researchers are using students instead of practitioners. This is okay for some things. So if it comes to writing code, for example, this can be okay, but you cannot run a controlled experiment where you try to check the architecting decision-making process, for example, because this is something that would not be well represented in students. You would actually need to do this with software architects. Now, the running example for this kind of study, an experiment we did a few years back, we wanted to see how patterns affect the documentation of architecture decisions. As you all know, documenting architecture's decisions is significant, and it helps us understand how the current system and the current architecture has come into place so that we can make changes to it. However, we know very well from literature that decision documentation is usually not done, or it's not complete, it's only partial, or it's out of date. So people don't actually go back to the decisions they documented to keep them up to date with along the system evolution. And of course, you can recover decisions, but that's expensive. You need to ask architects to do that, who are expensive people. And it's usually not applied in practice. Now, what we thought was, okay, recovering decisions may be expensive. How about if we base them on architecture and design patterns? If you look at literature, you know that the most important design decisions in a system actually have to do with patterns, not all of them, but many of them. And we also have this rich description of patterns. If you think of, layers in client server or peer-to-peer, this kind of patterns, publish, subscribe, and so on, you get a very nice description of those patterns from books or papers. So you can actually reuse this description to document your decision. So we said, okay, if we actually recover architecture decisions based on patterns, does it help? Particularly, does it help us recover more decisions and higher quality decisions? So we're interested in both on the quantity and the quality of decisions that can be recovered with the help of patterns. There are two types of experiments. The first one is human-oriented and the second is technology-oriented. When it comes to the first one, we give humans different treatments. So for example, they can use a tool or not use a tool or use different tools for specific objects like source code or maybe architecture description. And in the human-oriented type, we have less control over the variables. The humans are, sort of unpredictable, so they can, of course, do different things depending on context and circumstances. And they also have the so-called learning effect. So if you give two different treatments, let's say two different tools to a participant, then for them, using the first tool has a learning effect, which is going to affect how they use the second tool. So this is something that needs to be taken into account. Technology-oriented experiments, on the other hand, is where you have automated tasks. You have tools that you apply to different objects. For example, you could have, I don't know, test generation tools. You have different test generation tools that you have them parse the same data set, and then you find out whether the test cases that are generated are good or not. Now, with respect to the variables of the experiments, I briefly hinted towards this before. In an experiment, we're interested whether there is a cause and effect between the independent and the dependent variables. So whether if we change the independent variable, does that cause also change on the dependent variables? The independent variables we call factors. We try to control all of the independent variables. These are called confounding factors. For example, if you have an architect and you want to see if they are documenting their decisions correctly, you can ask them to use a tool. Okay, so that's the factor. But it could also be that more experienced architects are better at documenting decisions, and it's not the tool that's helping them, it's the experience. So you need to control for this experience. You need to make sure that in your experiment, participants have a balanced experience among the group that you're studying. A treatment is another term we use to reflect a particular value of a factor. For example, using a tool or not using a tool or using a different tool. Now, treatments are usually applied to the combination of objects and subjects. Objects could be software code, it could be issue trackers, it could be architecture description, and subjects, in our case, it's usually architects, but also other kinds of software developers. And an experiment itself consists of a set of tests where we apply those treatments to the combination of objects and subjects, as I just mentioned. Going back to our running example, where we try to see whether patterns help to recover better and more decisions, these are the variables that we used. So at the top part, you see the dependent variables. And these are the things that we want to see if they change, right? So we are interested in quantity and quality of the recovered decisions, as I mentioned before. Regarding the independent variables, first one is the group. This is actually the one that we change. And this means that we either ask participants to use patterns or not, do it in an ad hoc way as they would normally do it, and see whether that affects the dependent variables. But of course, there's other independent variables, and these are the confounding factors, as I mentioned before, such as the affiliation, if participants work in industry or academia, the experience they have with programming, with architecting, with middleware, because our experiment is about middleware, and so on. So we want, again, to look whether the independent variable of group, whether using patterns or not, has an effect on the dependent variables by also controlling for the confounding factors. And I'm going to show you how we do that in just a couple of slides. So the next thing that you need to do is determine your hypothesis. In our case, we hypothesize that the quality and the quantity of the decisions that the participants recover is higher when they base it on patterns rather than when they do it in an ad hoc, intuitive way as they would normally do it. Now, if you remember your statistics course from when you were undergrad, you probably remember that accepting hypotheses is very difficult to do with statistical tests. That's why you usually try to reject hypotheses. And in that light, we formulate the null hypothesis of the ones that we previously stated. So the null hypothesis in our case would be that the quality and the quantity of the recovered decisions is of lower quality or at most of equal quality as the decisions recovered by doing it in an ad hoc way. The object that we use in our experiment was the JBoss J2E Enterprise application server. So we gave participants the documentation for this system. This includes a lot of, decomposition diagrams and information about interfaces and components and so on. And of course, we did not mention any patterns because that would bias towards the pattern group. So here are again all of the information about the independent variables. And this is where we are able to control for the confounding factors, as I mentioned before. So for each one of those charts, you can see that you have the control group on the left and the pattern group on the right. And you can see that the two charts, the left versus the right, is sort of equal. Not exactly, it's not usually possible to do it exactly the same, but they are pretty well balanced. So this means, for example, that programming experience is the same in both the pattern group and the other group. The same goes with architecting experience, with experience about middlewares, and whether you are in industry or in academia. So this allows us to say that, well, we split people into equal groups. So the only thing that changes between them is whether they use patterns or not. Then we go to instrumentation and blinding. We were able to have double blinding in our case. This means that participants are aware that they are in different groups. So they know that there's another group doing something else, but they're not sure what it is, what's the difference between the groups. And we also blinded the evaluators. These were the people that looked at the recovered decisions afterwards, and they were able to evaluate them and say, what is the quality of those recovered decisions? So we gave them a first questionnaire to find out about their background and the experience, and that I mentioned before. We gave them an example decision so that they know what it looks like. And then during the experiment itself, we gave them templates for documenting their decisions, a catalog of patterns to the pattern group, of course, not to the other group, as well as a wrap-up questionnaire. And if you're interested on what was the outcome of the experiment, well, it was quite simple and conclusive, actually. So we found out that patterns actually help with recovering more decisions. Sorry, I stand corrected. Patterns help with recovering higher quality decisions, but they do not help with recovering more decisions. So they give us higher quality, but not higher quantity. And we were able to explain this. If you're able to use good pattern documentation for your decision, in fact, you also are able to make a good description of that recovered decision. Okay, so that was experiments. Now the third and last category I wanted to cover was surveys. What do surveys do? They identify characteristics of a broad population of individuals. And so, of course, you've seen surveys in your everyday life. You hear about, what is the percentage of people that wants to get vaccinated versus not? How many people want to vote for the political party or not, and so on. We do the same thing in software architecture and software engineering. We do surveys where we find out what is the percentage of architects that do document their decision versus the ones that do not, and so on. Many people confuse a survey. They sometimes consider that it's basically a data collection instrument, like the questionnaire itself or the checklist, but it's not. It's a full-fledged research method, and it should be described as such. So the idea here is that you take a sample. You cannot ask all of the architects in the entire world, but you can take a sample of 50, 100 architects, and then try to ask them some questions that allow you to generalize from this sample to the rest of the population from which this sample belongs. Mostly surveys are using questionnaires, but you also see structured interviews, a lot of surveys with structured interviews, and sometimes data logging. So this is where you are monitoring Slack channels or other kind of work artifacts to see to kind of grasp the opinion of people. Surveys can often be investigations in retrospect. For example, you give architects a tool to use or a technique, you let them use it for a couple of months, and then you go ahead and ask them the questions that you want in your survey. Running example for this case was a survey we conducted to find out how architects reason. How do they actually basically follow some logical process, a few logical steps to come up with a design decision. The literature in this respect was telling us that architects really have very little guidance to support their reasoning process. Most of the times it's ad hoc, so they do it in their own way. A lot of the times it's biased. Human beings have a lot of biases, and of course architects are humans, so they tend to be quite biased. For example, if they are experienced with a specific solution, they tend to apply it over and over without checking whether another alternative might be a feasible solution for the problem at hand. Reasoning is also very experience-based. So experienced architects, in fact, have a much more mature and systematic reasoning process than inexperienced ones. But if you look at literature, the truth is that we don't quite understand how people do this reasoning process, and that's what we wanted to find out in our study. So we did a survey with 53 architects from the industry to find out how they reason in the real world, in real life. Again, this is an in vivo type of study, in contrast to experiments, which is in vitro. And then we took the results and we were able to discuss and interpret them with respect to the context, how people belong to different application domains or different organizations can vary in this sense. And also we compared it against literature. Finally, we derived reasoning best practices, so things that architects can follow to improve their reasoning process. Now, there are three main types of survey: descriptive, explanatory, and exploratory. So descriptive survey means that you are able to formulate assertions about a population. Again, this sort of percentages, like 30% of people do X, 50% of people do that. Explanatory surveys are more about the why. So you know that something is happening, but what you ask is, why does this happen? Why do people do this? Why do they choose that? And so on. And finally, exploratory are usually preliminary studies where you don't quite understand something. So you want to do this initial step to sort of understand the main issues behind the phenomenon, and then you can follow this up with, let's say, a descriptive study or an explanatory study. Surveys can be either cross-sectional or longitudinal. Cross-sectional means that you just ask people at one given point of time, and that's it. Longitudinal, you can do this over a period of time, so you can ask them today, and then a year later, and then 2 years later. There are longitudinal studies in other fields that last for a very long time. There's this famous Harvard study that has been going on for 75 years, I think, about the well-being of people. In software architecture, we don't have 75 years, so sometimes you see longitudinal studies that go on for 1 or 2 years. So back to our running example, this was a descriptive study. So we wanted to find out how software architects reason. We use the architecture design process from Hofmeister et al. If you remember this, it's about analysis, synthesis, and evaluation. So how do you see the problems versus problems/requirements? How do you come up with solutions, and how do you evaluate those solutions? So this mapped to our 3 research questions, and we had a cross-sectional design. So we asked them at one given point of time, because usually people do not really change the way that they are doing these things, at least not in the short term. Now, usually you can follow 2 instruments to collect your data in surveys. Either you interview people or you ask them to fill in a questionnaire. And these have pros and cons, depending also on your goal. So with interviews, you have a higher response rate. Usually when you agree with people to be interviewed, they show up instead of bailing out on you. In a questionnaire, you usually don't have a high response rate. Sometimes it's 10%, but you can have a larger sample. So you can invite 1,000 people to take the questionnaire, and then maybe 100 will respond. And you don't have to synchronize in time and place. You just put it on the web and ask people to fill it in. With interviews, you have the flexibility to go deeper. So they say an interesting answer, and then you follow up and say, okay, let's discuss this a bit further. Questionnaires are not interactive, so you have some questions there, and that's basically it. You don't have a chance to follow up. Interviews, you can decrease or maybe even eliminate the the number of I do not know or I cannot answer this, because you can explain to participants the question and you can try to give them enough information to answer. With questionnaires, yeah, you're not really doing this in synchronized mode, so you cannot explain anything. Interviews have higher effort. If you get like an hour of interview, it takes you 3 hours to transcribe it. That's already quite some time. Surveys are usually more inexpensive in that sense, because you can get the results from Google Forms or something, and then crunch the numbers in some statistical package. So in our case, these were examples of questions we asked. For example, Q7, we asked architects if they search for alternative design options when making decisions. We did the survey through a self-administered questionnaire, so they would just have to go to a web page and fill it in. We mixed structured and unstructured questions, so open-ended questions were also there for us to get a bit more deep information. And we did a pilot with 4 architects from the target population. This is really important for validity. We'll cover validity right at the end of this lecture. One really important aspect of surveys is sampling. Remember that you have a population and then you select a sample from that population, which hopefully will allow you to generalize back to the population. This means that you need to avoid bias. If your sample is biased, then you cannot really make a generalization. If you make a survey and only the top, I don't know, Microsoft architects respond to that, this is a rather biased sample. If you can imagine, you can basically generalize to experienced architects of very large companies. So you need to make sure that your sample is as representative as possible, and it's also appropriate. Again, if you ask students to fill in a survey about architecture decision-making, this doesn't really represent the population of architects at all. Third criterion is cost effectiveness. It should be relatively possible to ask to do the survey with these people. This means that you do also need to make the survey relatively short. You cannot ask people to fill in a survey that takes 2 hours. And in practice, we see a lot of convenience sampling. This means that, for example, I have a few friends who are architects and I go to them to fill in my survey. You can see that this can be biased, so you should be able to randomize as far as possible your sampling in order to be able to have a good representative sample. In our case, what was our sample? We were able to ask practitioners that had at least 5 years of experience in industry and at least 2 years of experience in architecting. We would exclude data points if the daily tasks of our participants did not include one of requirements engineering, system architecture design, or software design. And we also used chain referral sampling, which means that the people that fill in the survey, we ask them to also refer this to their colleagues so that they can also fill it in. Another really significant aspect of surveys is the context. You see a lot of surveys where the population is very vaguely defined and you're kind of struggling to find out what exactly do they mean, what is the actual population here. A lot of surveys not well designed are aimed at all of the software engineers in the entire world. This is basically mission impossible. There are a lot of smaller subgroups, people that work in different countries, in different continents, that have a different job description, that have different tasks within the organization. So you need to be as specific as possible with respect to the context. What exactly is the population that you're trying to represent here? What was the context in our case? So we asked people about their experience, about the project, about the organization, and our sample had an average of 18 years in industry and about more than 10 years experience as architects, which is pretty much what we were hoping for. In the pie chart, you see the organization size. So most of the participants were in large organizations with more than 250 employees. And then the table has the project characteristics, how many lines of code, how many person months, how many architects, and so on. So we were relatively happy because the variation here is relatively good, and we are able to generalize to a number of different architects and organizations. What was the result of our survey? We found out that architects usually try to get a very deep understanding of the requirements. So they spend a lot of time doing that. But as soon as they have the requirements, afterwards, they actually seldom relax those requirements. They also search for, they don't usually search for options if they already have a solution in mind. So if they are trying to solve a problem and they say, okay, I know that this technology works or this pattern works, usually they stick with that. They don't try to figure out if there is something else that could be a better solution. They usually take one decision at a time, not groups of decisions at the same time. They don't often reject decisions, which is, to us, it was not very intuitive, but that's what happens in practice. And the most important things in making decisions was to understand the problem domain and also to do a thorough exploration of the solution space. Finally, there was no specific order in decision making, so decisions were actually made on a kind of first come, first serve basis, or depending on their priority. All right, last part of my talk is about threats to validity. There are people that usually underestimate this as, okay, this is a little section at the end of the paper. Let me just do my study and then I'll write a few words there. to address reviewers' concerns. That's usually not a very wise approach, because if you have large threats to the validity of the study, it will completely invalidate everything that you've done. So threats to validity is not supposed to be an afterthought. I'm presenting this at the end of my lecture, but probably I should have put this right in the beginning, because this is the most important part of the study, to make sure that you've covered all the threats to the validity of the study. It's part of the study design, as I mentioned, and this is also a common misunderstanding. So people tend to treat threats to validity as the same, and sometimes you see threats that are meant for experiments being applied to case studies. Not a good idea. So different types have different threats. So you should try to make sure that you are applying the right threats according to your study. So let me go through the main threats to validity. These are not all of them, but these are definitely the main ones. Construct validity. This is asking, are we measuring what we're interested in measuring? Consider our experiment on the patterns, whether they help us recover more or higher quality decisions. So if we are measuring the quantity and the quality of the decisions, and quantity is straightforward. We gave people a piece of paper to fill in. Every piece of paper is one decision, so you can add that up. But quality we measured by only one variable. Namely, we asked experts to rank the quality of that decision. And that is a threat to the validity. If we had a second variable to confirm the findings of the first, that would have been better done. Unfortunately, we couldn't do it, yeah, we had to admit it in the paper that we have not completely mitigated this particular threat. In terms of internal validity, this is about causality, so mostly about experiments. This is asking, is the factor responsible for the effect? So again, we go to the patterns experiment. We had, if you remember, two independent variables, no, two dependent variables and a bunch of independent variables. We try to balance the variables related to the subject. If you remember the experience in architecting, in industry versus academia, in the middleware systems, we try to balance them, and we did a relatively good job in that. The only threat that we couldn't quite mitigate and is a potential confounding factor is that the system we chose is actually quite rich in patterns. So this could have biased the patterns group to document better decisions, higher quality decisions. We explain in the paper why we think it's not the case. With threats, it's not your job to completely mitigate them, but you should at least explain the extent to which you're able to do that. External validity asks whether the results are generalizable to other contexts. So I'm looking at a sample and I want to generalize to a population. How far can I do that? If you think about the case study that I showed with the tool that we developed for ABB, we had a number of professional architects, and they had a very nice experience in architecting, in industry, a lot of diversity there. So the sample was actually quite good. What can we say about generalization? We can say that, yeah, we can generalize it to architects that work on industrial organizations similar to the one that we studied. So we cannot really generalize to an SME, and we cannot generalize to a company on, I don't know, doing a completely different application domain. We can identify at least the companies, the organizations that we are able to generalize. Reliability is about how biased the researchers bring into the process. So Does the data collection and data analysis depend on who is doing it? And in our case study, we had, if you remember, 4 different sources of data. So that allows us to triangulate, and we were able to see that, you know, what we learned from the interviews is actually confirmed with what we learned from the focus groups, which is a good sign. We did a pilot study to train our interviewers. We had open-ended questions so that we can reduce the bias of the interviewers. And the analysis was done by 3 different researchers independently, and then we rated their agreement. So to some extent, we were able to do a good job in mitigating reliability. Again, you cannot mitigate everything perfectly. And finally, conclusion validity. This is about studies that have quantitative analysis, and it's concerning the statistical significance, especially when you're studying causality. In our patterns experiment, if you remember, we used evaluators to examine whether the recovered decisions were of high quality or not. There we use the Likert scale. So Likert scales are by definition at least nominal. They can be considered interval, but not necessarily. And for our statistical tests, we needed interval variables to be able to run the tests. So we had to explain why, in our case, we could consider a Likert scale to be interval instead of only nominal. So that's basically more or less it. I'm presenting here my favorite books of all time when it comes to empirical software engineering. There is the Bible of case studies, the Bible of experiments, and finally, a Guide to Advanced Empirical Software Engineering, which contains everything else. So I would really warmly recommend you guys to read these books. They're absolutely a must read when doing empirical research in our field. And if you want to know more, you can always come to the main conferences, which is EASE and ISAM. And there's also a network called ICERN that is a get-together every year of empirical researchers that discuss these kind of things. I'm usually there, so I'd be happy to meet you in one of those meetings. And that's it from my side. Thanks a lot for your attention. If you have questions, please note them down now. We are going to devote about half an hour during the school to discuss this lecture, and I will be able to answer your questions, or maybe not. We'll see. But I do look forward to seeing you guys there. Okay. For now, take care.